Okay, so I have started the camera. If you can see in your syllabus, there is an multi-point fuels. Okay, multi-point fuel injection system, fuel transfer pumps, fuel filters, fuel injection pumps and injectors. Okay, then next is an electronic injection system and direction common rail direction injection system. So this is what I am going to, this all concept today we are going to clear now. Okay, so we are going to see the injection systems. Okay, that's a multi-point and single point injection systems. Okay, then the fuel injection pumps we are going to discuss, electronics injection system is we are going to discuss, and common rail direction injection systems. With the diagram I will try to explain today. So by covering to, if you by today's class we will cover overall syllabus, okay, of the fourth module. Okay, so we'll go for the, I will like to share some screen for you all. So see the injection system and the injector. Okay, so there are so many difference between the injector systems and the injector that you are going to study now. Just I will share the screen and we will go for that one. Just it is loading. Okay, now it is come. Okay, now dear students, if you are having any problem regarding the diagram, you can tell me, so I will zoom it or minimize it. Okay, so let us start. So this is the on the screen you can see the multi point fuel injection system. It is a multi point fuel injection system. So see this is a very important diagram. Okay, so this shows the multi point fuel injection system. You can also describe by this diagram, as well as the common relay direct injection system also you can describe by this diagram. This is a common diagram for both the multi-point injection system and common relay direct injection system. So in the further slide I will explain regarding the common relay direction system, how does it works. Okay, slightly changes are there in the diagram, but you can show this diagram for the both the concept multi-point and common relay direction systems. Okay, now let us see the multi-point fuel injection system. What do you mean by the multi-point fuel injection system and how does it works, and what are the construction features are being used in this system. Okay, so see the fuel injection methods. Okay, why does the fuel injection method is been identified or been invented? Okay, what is the use of them? The fuel injection methods are used for admitting the fuels in SI engines. Okay, so see the injector is used in an SI engine, that is a diesel engine. The injector is required to inject the fuel in the diesel engine, that is an SI engine, internal combustion engine. This thing you have to keep in your mind. So the multi-point fuel injection system, automobiles or the cars or the vehicles which has been used are called as an MPPFI. MPFI means what? Multi-point fuel injection system vehicles are being used for injecting the fuels in the engine according to the requirement. Okay, so the each cylinder having an each injector. So you can see in the diagram, I will go with the diagram construction. So each cylinder having the each injector. If it is an the engine which is having the multi cylinders, okay, so the multi means what? Two. If is having the two cylinder engine, so two injector has been used. So three cylinder engines, three injectors are being used. So each and every cylinder of the engines, one injector is required. Okay, this thing you have to keep in mind. So it is used to increase the engine efficiency. The multi point fuel injectors is been used to improve the fuel efficiency of the engine as well as the engine efficiency. Okay, if the fuel is been supplied properly to the SI engine, so it will burn properly and produce the more power output, or the workload can be done by the engine as well as the mileage or the average of the engine will be very good and proper. So for the proper burning of the fuel, these types of multi-fuel engines are being used. Now let us see the construction. So see dear students, in the construction you can see over here, this is the cylinder head or the cylinder in which the pistons are moving. Okay, cylinder head is there, and these are the inlet wall. Okay, at the top you can see inlet wall from where the air fuel mixture is been going, and this is an manipulator. Okay, now this is the common relay. Okay, common relay. What do you mean by the common relay? So see, these are the injectors. In the black color arrow marks are there, you can see over here. So these are the injectors. So black color arrow marks are, these are the injector which injects the fuel inside the cylinder, and this is a common relay. This common relay is nothing but an tube, copper tube or the metallic tube is there, in which the continuous fluid is been supplied to each every injector. So this is a common relay. Okay, now you can see this common relay is connected with an metric distributor. So this metric distributor is nothing but an electronic device or the electronic control panel which distribute the equal amount of the fluid, okay, for each and every injector. Okay, if the fuel is supplied by the metric distributor, each and equal amount of the quantity, okay, injector, the excess fuel is been remained in the uh, common relay. Okay, this is called as a common relay or the common joint for the each and every injector. Okay, now this is a fuel tank. Main fuel tank is there, and this is a filter, and this is a fuel pump is there, and this is a pressure control device is there. Okay, and over here you can see there is an air filter is there, from where the fresh air is been inserted inside the engine cylinder. Okay, so this is what the simple construction of multi-point fuel injector. Now let us see in the next diagram working of this multi-point fuel injector. Okay, now see, the main fuel from the main fuel tank, okay, is passes to the filter, in which the fuel is been filterized. Any contaminants or the dirt particles or any unwanted particles are been filtered by the fuel, and it is transferred to the fuel pump. Okay, in this fuel pump, okay, these fuel pumps are two types. Okay, one is a mechanical fuel pumps and another one is an electrical fuel pump, which are being used most in the what you can say, the automobiles, that's are the car, trucks, buses. Okay, so the mechanical pumps is a rare one nowadays. The electronic pumps, the hybrid cars are coming, the electronic pumps are being used. So this fuel is being pumped to the pressure control, where the pressure is being controlled. Okay, the high pressure fuel which is coming from the fuel pump, over there the pressure is been controlled, and whatever the required pressure is been required, whatever the pressure is been required for the metering, for the distribution, for the each of the injector, that pressure is been controlled in this pressure valve. From over here the fuel is transferred to the metering distributor. From this metering distributor, you can see in the diagram, the fuel is transferred to the injector when the cylindrical wall is been open during the combustion time. At that moment the required amount of the fuel with including the air, okay, both the air and the fluid mixture is been inserted into the cylinder, okay, for the combustion purpose, okay, in the SI engine cylinder, okay. Then afterwards you have studied regarding the wall timing diagram is been given, okay. Wall timing diagram or the wall timing is been set as per the wall timing set in the multi cylinder. So the timing of the first cylinder wall is been closed, okay. At that particular time that wall will be closed and the next second wall will be open of that cylinder. Then whatever the fluid is to be supplied with the air is supplied to the second cylinder, and the metric distributor supply the fuel with an air to the second cylinder. Then for the third valve, then the second valve closes, then the third valve opens. At that moment whatever the fluid is there, that will be supplied. If with then 4-stroke engine, that if there is an 4-cylinder multi-cylinder 4-stroke engine is there, then the first and the third will be open, then the second and the third will be open. It depends on the engine wall timing diagram how the alternate both are opening or single cylinders are single walls are opening by sequence wise, okay. It depends on the design of the engine as well as the wall timing setup, okay. As per the opening of the wall, the matrix distribute the control system is been done, or the controlling unit is there, or the controlling device is there, in which by which the multiple injectors has been fuel is been provided. For the multiple injectors the fuel is been provided by the metric distributor, including with an air. The air is been separately, not including, the air is been separately supplied to the cylinder, okay, by when the wall is been opened. So like this way the working procedure is often multi-point fuel injector is been working. Now we will go for the next topic is a single point cylinder, okay. Now see, in the multi-point cylinder there are multiple injectors are there, and the multiple sources are there to supply. The metric distributor is been used and the common relay is been used. Now over here there is a simple diagram is there, only single injector is there. This is used for the for a single cylinder single point fuel injector, which can be used for the multi cylinders also. Now you can see over here there is a common manipulator is there, from which the common air and the fuel is been supplied, and over here the fuel is been given, and this is what the injector is there. At the top the manipulator or the throttle is there from sorry, from where the air is entering as well as the fuel is been injected with the common manipulator, okay. It enters into the walls. When the wall is been opened, it enters into the cylinder, okay. So the opening and the closing of the wall is been done by the wall timing adjustment is there. According to that calculation the opening and the closing of the wall is been done. When the wall is open, the fuel and the air mixture is been inserted inside the cylinder for the combustion purpose. This is how the single point fuel injector works. Only over here the single fuel injector is been used, okay. So this is what the difference between the multi point and the single point fuel injectors, okay. I hope you have understood this one. If you have not understood, write a comments in your WhatsApp group, so I will clarify. Now next, see over here there is an fuel pump is there, okay. You have in this diagram you have seen there is an fuel pump is there. So see, the fuel pumps plays a very important role in the injection systems, okay. So there are two types of fuel pump. One is an mechanical fuel pumps and another one is an electrical pump, okay. That we will see how does it works and what are the construction features of this pump. So this is the diagram of an electronic pump. So see, this is a diagram of an electronic pump. So this will be the easy to explain you. So see, this electronic pump works on the solent theory. Okay, the solent device is being used for the working of this electronic pumps, and the advantage of this types of pump is that without starting an engine, the fluid can be supplied to the engine. Okay, there is no need for the start of an engine because it is directly connected to the battery. With that help of the battery, the continuous power is being supplied to the solent, okay, by which the engine the fuel is been started. Okay, there is no need to ignite the circuit, okay, so that the pump can be started. This is what the major advantage of this engine. Now let us see how what are the construction and how does it works. Okay, the so see, before going for this, the solent device is nothing but it is being used to convert the electrical energy into mechanical energy. First keep in your mind. So how the mechanical energy is been converted over here? Because of the solent, the magnetic coil is been used, by which, so in this diagram you can see these are the magnetic coils which produce the magnetic field, by which the movements of the mechanical device can be done. Okay, so this is how the solent device works and activates over here. Now let us see the construction. What are the construction and how does this pump work? Now see, this is a battery which is connected to the power supply or the armature. Okay, not power supply, sorry, the armature. Okay, by the armature you know that how the armature works and how does it generate the current. Okay, by the armature it is the power is been stored in this battery. By this battery the power is supplied to the solenoids. Okay, over here there are the magnetic coils are there, and you can see this is a pull rod is there, and this is a pull rod is there, and this is a contact point. Okay, these are the, there are two shoes are there. Now you can see the contact breaking rods are there. There are the two shoes are there. There are two shoes are there, okay, which are joining with each other. Okay, now I will tell you how, what will happen when it's joins. Okay, and this is a spring load is there, which is used for the compressions or the for the applying the load. Okay, and over here you can see there is a diaphragm is there, diaphragm spring is there. Okay, and over here the iron disc is there. Okay, now over here you can see there are the two walls, wall number V1 and this is a wall number 2, and below the diaphragm over here there is an open tank is there. Okay, the oil is inletted from over here, it comes to passes by this wall, comes to this tank, and once again enter this wall number 2 and passed away. Okay, now you can see there are the two openings are there which are connected by the spring. Okay, and this springs is directly connected to the diaphragm. So this is what the simple construction of an electrical pump. Now let us see how does this work and what the silent phenomena is done inside there. Now see, the main power is being supplied by the battery, and also this electrical coil is connected to the earthing of the armature. When the power is supplied in this magnetic coil, the magnetic flux starts to generate. When this magnetic flux starts to generate, the magnetic force is being generated. This magnetic force convert the electrical energy into mechanical energy. How does the mechanical energy works? Now see, the power is being supplied, the when the power is being supplied, just now I told the magnetic force is generated. This both, when magnetic force is generated, this pulling rod, okay, moves at an upper side. By the generation of the magnetic force, the mechanical energy starts to generate. This pulling rod moves at the upper side. Okay, when this pulling rod moves upper side, this diaphragm, okay, which where there is having the diaphragm spring, okay, by with the help of this magnetic force, with the this diaphragm moves at the upper side. When this diaphragm starts to move at the upper side, the wall number 1 and the wall number 2, which is attached by the means of a spring, okay, also starts to open. Okay, when it starts to open, the flue by the passes through the filter, enters in the help of this opening of this wall 1 into this tank, okay, and pass to the wall number 2, from where this fuel enters to the carburetor, okay, where in the carburetor it mixes with the air and transferred to the injector, okay. So this is how the fuel enters inside and passes away. Then afterwards the timing is being set, okay, for the cylinder. So at per that timing the magnetic flux is been cut, okay. So when this magnetic flux is been had been cut, so this both the shoes come into an contact with each other, okay. As the magnetic flow force starts to reduce, then the spring starts to apply its pressure. The pressure of the force of the magnetic force reduce, and the pressure of this upper load spring is to increase simultaneously. One side it is reducing, one side it is increasing the spring pressure. As the spring pressure increases, both the contact points touches with each other, and this pulling rod also come at a downwards. By the help of this diaper screen, the additional force is being applied. When this diaphragm comes at this level, so this both the wall V1 and V2 are been closed. So the supply of the fuel is been stopped for the carburetor. When the cycle of the engine or the piston, okay, completed, when it comes to its once again to its position for the combustion, at that according to that timing of the opening of the wall, okay, of the engine wall, this cylinder timing is been done. So when the engine wall starts to open and ready for the intaking of an fuel and the air mixture, this cycles once again start, the cyanotizer starts to work and generate the magnetic force. So like this way the continuous cycles is been done, opening the force, reducing the force, increasing the force, decreasing the force, okay, magnetic force, which electrical force, which is converted into a mechanical force, as the magnetic flux is been playing a main role for changing the electrical energy into a mechanical energy. So this is how the cycle is been done for supplying the fuel to the carburetor. So this is how the electrical fuel pumps work, okay. Now the mechanical pump is there, it is in the next slide. Before going to that slide, I will cover your next concept, that is an common rail direct injection system. So see how the common rail direct injection system works and what are the things are there that we are going to study. Now see, in this topic you can see there is some meaning is there for that common rail injection system, okay. So that is also called as an CRDI injection system, okay, common rail direct injection system, and we will going to see the merits, now the constructions and the workings of that one, okay. So see, the common rail direct injection system is been used for improving the engine efficiency. Maximum amount of the fuel can be supplied for that engine, so the maximum amount of the fuel can be burned, ignition delays to be avoided. So this is what the main function of or the importance of the common rail direct injection system. For the continuous supply of the fuel to an injector, a common tube is being used. Common tube either may be the copper tube or any other tube is being used, okay, from which the common fluid is being supplied at that middle of that tube, or at the that common pipe, you can say the common pipe, the one of multiple injectors are being joint, okay. By that injector, these injectors are directly inserted into an engine cylinder, from where the fuel is being supplied to the engine, okay. So that is why it is called as a common rail director, because at a common pipe the multiple injectors are being joined, from where in the first diagram in the multi-point injection system I have shown that where is the common rail is there and what is the use of that one, okay. Same thing is there. Now let us see the merits. Or merits means the advantage, that advantage of this common rail is a more power. Okay, it can produce the high efficiency of the engine if you are using this system, and the mileage or the average of the engine or it can be improved because the maximum fuel is been supplied and the maximum fuel is been burned over there. Whatever the fuel is been supplied, that has been burned properly. So not maximum fuel, you can tell whatever the fuel you are using, okay, that fuel is completely burning over there by this system. Okay, and then the high pressure injection is been generated. Okay, the injector uh, by adding the extra fuel which is reserved in the tube or the pipe, okay, by which the pressure of the injector doesn't drop over there because the continuous fuel is been supplied to the injector by the means of common rail, as well as the pump is also there. Okay, so this is what the advantage of the common rail injector. Now you can see, so see dear students, this is one of the last 10 minutes are there. I will go it fast. Okay, otherwise we are unable to cover the pumps. One more pump is there. So see dear students, this diagram you can draw for the two concepts. One is an electronic petrol injection system as well as common rail direct injection system. For both you can draw the same diagram. Now you can see over here in the construction, over here there is an injectors are there, 1 2 3 4 injectors are there, and this is what the common full rail is there. Okay, common rail is there where the fuel is been commonly filled. From this common fuel, for it is supplied to each and every injector. Now you can see over here there is a sensor is there. Okay, how much quantity of the fuel is to be supplied or the coming out. Okay, there is a sensor, we will see which sensor it is. Okay, and this is a fuel pressure, high pressure fuel pump is there. Now over here one more, the pressure control valve is there to control the pressure which is supplied from the pump. Okay, and over here the air fuel filter is there, and this is a low pressure fuel pump is there, from where the pressure is been reduced at a low quantity and it is supplied to the tank. Then once again it comes to the roller. After completing the fuel is supplied to the injector, whatever the excess the fuel is there, once again it's go to the pressure injector. Like this way the circulation is been done. Now you can see over here EMU is there, EMU. Okay, now you can see there are the small wire connections are been given to the injector. What do you mean by the EMU? EMU is an engine management unit, or you can say managing unit. This is an electronic circuit. Nowadays you have seen the hybrid cars are there which also works on the electricals. Okay, so this hybrid cars nowadays are being used by the electronical wiring or controlling units, or the systems are been there by which the fuel sensors are there. Okay, different types of sensors are being used. With that help of that sensors, you every fuel indications, service indications, every indications are been shown, oxygen indications are being shown. So this EMU is connected to such type of sensors and controls each and every parameters of the engines. Okay, of the fuel supply, you proper the proper, what you can say, the proper quantity of the fuel can be supplied, has been controlled by the EMU. Okay, oxygen is been controlled by the EMU. Now let's see which types of sensors are being used. Throttling position sensor, throttling position sensor which is located near the carburetor. Throttling position sensor means what? The throat is there from where the air and the fuel, both the mixture is been coming out. Okay, so over there the sensor is been kept to identify either the fuel or the air mixture is coming in the proper manner or not. Manipulate absolute pressure, manifold absolute pressure sensor. So this pressure sensor is kept over here. You can see the pressure sensor from where, or it can be located near the control wall. It is almost near the control wall, from where it shows how the pressure, how much the pressure is coming out, how much quantity the pressure is coming out okay, either the pressure is out of control or the pressure is within the limit, okay, it transfers the data to the EMU from where it controls the pressure. Even the oxygen sensor is there, which is located near the pressure control valve or near the carburetor. So how much percentage of the oxygen is supplied to the carburetor? Air, okay, air, that is an air is supplied to the carburetor, and the mixture of the air fuel, that is an oxygen and the fuel. The next one is an next sensor you can see over here, the crankshaft position sensor. Okay, in the crankshaft position sensor, the movement of the gears, okay, and the movement of the load on the crankshaft, whatever the engine is delivering the output, whatever the engine speed is delivering the output, at that same output the crankshaft is rotating or not, or any changes is there. Because if the engine having any changes in the combustions or the cycle system, so the output will not comes in a proper manner. If the output is not come in the proper manner, the crankshaft speed will be not be in that the crankshaft or the engine load will be less, or the engine doesn't give the proper load. If the engine is moving in a high speed but the crankshaft is moving in a low speed, that is to be identified. What is the mistake is happening over there, that can be identified if you are having the parameters to check the engine speed as well as the crankshaft speed. Whatever the engine delivering the speed to the gearbox, that speed should be transfer, same speed should be transferred to the crankshaft. That is to be that can be identified by the crankshaft position sensor. Okay, now there is a fuel temperature sensor is there. This sensor works to identify the temperature of the fuel which is supplied to the engine. Okay, the fuel it should be initially at a cool temperature, then when it comes out of the, when it's go for the combustion, it will be heated over there. Okay, so these are the sensors which are being used for the working purpose. Okay, so now let us see the working of the common rail direction system. So say simple it is, how does the multi-point cylinder is been work over here. There are common from the fuel tank, the fuel is been supplied over here for the common rail. Okay, in the common pipe you can say it is an either it may be the copper, whatever the pipe they are using, common pipe is there from where the fuel is supplied for the each and every injector. Okay, then whatever the excess amount of the fuel is there after supplying to the injector, that has been once again transferred to the, okay, by the fuel pump. It has been sucked by the fuel pump and it is in transfer to the fuel control valve, from where it transferred to the filter where the fuel is been filterized and the fuel pressure is been reduced, and it transferred to the fuel tank. This is how the cycle of the supply of the fuel is been done in then common rail director injection system. So this is what the injection system works, common rail. Okay, so this is simple construction is there, and you can draw the same diagram and the same concept for electronic injection system. If you are drawing the common rail injection system, there is no need, so see there is no need to draw the sensor. Okay, this much diagram is sufficient, this diagram is sufficient to draw the common rail. If you are going for the electronic injection system, so you have to draw EMU also and these types of sensors also. So it shows that the electronic components, when you go for the electronic injection system, so you have to show the sensors. Okay, now let us see the mechanical pump and the mechanical petrol injection system. Okay, I will share the screen now. Two, two, five. So see, for the multi-point fuel injection system in the 2D diagram, okay, you can draw this simple diagram and write down the explanation. Okay, simple, this is the 2D diagram. If you can draw this one if they ask, and this one is a single point injection system. Okay, if they can ask, you can draw. Just for your explanation, I have just shown this one. Okay, see, now this is a mechanical fuel. So say this is a simple construction, it is a mechanical fuel, but nowadays it has been not used in everywhere. Okay, so the common it, so the old vehicles they have been used. Okay, so you can see over here there is an eccentric camp is there. Okay, and this camp is connected to the engine crankshaft, and over here you can see the rocking arm is there. Okay, so first, before see the construction, this is an eccentric camp is there which is connected to the engine crankshaft. So this fuel pump works with the power supply for this engine pump is supplied directly by the engine only. Okay, no electrical or external source are being used over here. Oh.